Welcome to Science to Sleep By. Tonight, as you lie back and let the day slowly dissolve, imagine the ground beneath you gently fading away. Above your head stretches the Milky Way, a soft river of starlight, calm and unmoving. Or at least, that's how it seems. But in reality, this entire galaxy, every star, every planet, every memory ever made on Earth, is traveling through space at mind-bending speed. Not spinning wildly, not rushing chaotically, but gliding slowly, silently through a universe shaped by gravity, dark matter, and time itself. Tonight's story is not about explosions or catastrophe. It's about motion so smooth, so vast, that you can only feel it when you stop trying to. This is the story of where the Milky Way is actually going, where we are going, and how the universe carries us forward. Even as we rest. So take a slow breath. Let your thoughts drift outward, and allow the cosmos to do what it has always done best: carry you gently into the dark. On a clear night, far from city lights, the Milky Way stretches across the sky like a quiet, luminous cloud. It appears calm, almost fixed in place, as if it has always been there and always will be. For most of human history, this apparent stillness shaped how we understood the universe. The stars felt permanent, reliable, unmoving, a celestial backdrop against which the drama of Earth unfolded. Yet this sense of calm is one of the greatest illusions nature offers us. In reality, nothing in the cosmos is truly still, and the Milky Way is no exception. The illusion begins with scale. The galaxy is so vast that its motion is impossible to perceive from our short human lifetimes. When you watch a mountain from a distance, it seems immobile, even though tectonic forces are constantly reshaping it. In the same way, the Milky Way's motion unfolds across millions and billions of years. From night to night, from generation to generation, the changes are too subtle to notice. The sky looks the same because our lives are brief compared to the slow choreography of galaxies. Even within our own solar system, motion is everywhere. Earth rotates on its axis at about 1,000 miles per hour at the equator, yet we feel no rushing wind, no sense of spinning. The planet orbits the sun at roughly 67,000 miles per hour, and still, the journey feels perfectly still. This is because motion at a constant speed is gentle and unremarkable to our senses. We only feel acceleration or sudden change. The Milky Way's motion is smooth and steady, and so it passes beneath our awareness like a calm current carrying a drifting leaf. Our sun is not anchored in one place within the galaxy. It orbits the center of the Milky Way, completing a vast circular path once every 230 million years. That means the last time our solar system was in this exact position, dinosaurs were just beginning to roam the Earth. Since then, the sun has carried the planets through different regions of the galaxy, through spiral arms, past clouds of gas, and alongside countless other stars on their own slow journeys. Yet when we look up, the stars seem locked in their familiar patterns, unchanged and eternal. Those patterns themselves are another part of the illusion. Constellations feel ancient and permanent, but they are temporary alignments, shaped by our perspective. The stars that form familiar shapes, like Orion or the Big Dipper, are not moving together as a group. Each one follows its own path through space, with its own speed and direction. Over tens of thousands of years, these patterns subtly distort. Given enough time, they will dissolve entirely, replaced by new shapes no human eyes have ever seen. Beyond the motion of individual stars lies the motion of the galaxy as a whole. The Milky Way is rotating, its spiral arms slowly sweeping through space like the hands of an unimaginably large clock. Billions of stars participate in this rotation, bound together by gravity and guided by the invisible scaffolding of dark matter. From our position inside one of the spiral arms, this motion is impossible to sense directly. We are moving along with the flow, like passengers on a smooth train gliding through the night. The stillness we perceive is also reinforced by darkness. Space is mostly empty, and without reference points, motion becomes difficult to detect. On Earth, we know we are moving because we see trees pass by, or feel the wind on our faces. In space, there is no rushing air, no nearby objects sliding past our vision. The stars are so distant that even as the galaxy moves, their relative positions change only by tiny amounts. Motion without friction, without sound, and without obvious landmarks, feels indistinguishable from rest. Human perception evolved to navigate forests, plains, and coastlines, not intergalactic space. Our senses are finely tuned to notice a predator's movement or the shifting of weather, but they are not built to grasp velocities measured across light years. The brain interprets stability when changes occur too slowly to register. As a result, the Milky Way feels like a painted dome rather than a dynamic system in motion. This mismatch between cosmic reality and human perception deepens the illusion of stillness. Time itself plays a role. The universe operates on timescales that dwarf human experience. Stars are born, shine, and die over millions or billions of years. Galaxies collide and merge over spans of time longer than the entire history of complex life on Earth. Against such a backdrop, a human lifetime is like a single frame in a very long movie. Watching only that frame, everything seems frozen. Only by studying the universe through physics, mathematics, and observation do we begin to glimpse the movement hidden behind the still image. Scientific instruments help peel away this illusion. By measuring tiny shifts in starlight, astronomers can detect motion even when it is invisible to the eye. These measurements reveal stars drifting, galaxies approaching or receding, and the Milky Way itself traveling through space. What feels like a static sky is revealed to be a restless, evolving system. Yet even with this knowledge, the emotional impression of stillness remains. When we step outside at night, the stars still feel calm, distant, and serene. This illusion is not a flaw. It is a gift. The apparent stillness of the Milky Way offers a sense of peace, a reminder that we are part of something vast and enduring. Knowing that the galaxy is moving does not shatter this calm, it deepens it. We are not standing on solid ground in a silent universe. We are being carried gently through space and time. The motion is so smooth, so graceful, that it feels like rest. As you look up at the night sky, it is comforting to remember that stillness does not mean stagnation. The Milky Way is alive with motion, quietly unfolding its journey through the cosmos. The calm you feel is the calm of steady movement, of a universe that changes slowly and patiently. In that sense, the illusion of stillness becomes a bridge between human experience and cosmic reality, allowing us to rest peacefully while the galaxy carries us onward, unseen and unfelt, through the dark. When we imagine the Milky Way moving, it is natural to picture it spinning quietly in place, like a slow celestial pinwheel. While that rotation is real, it is only a small part of the story. The true motion of our galaxy is far richer and more profound, unfolding on scales so vast that they stretch the meaning of direction itself. The Milky Way is not simply rotating where it formed. It is traveling through the universe, carried along by the gravitational architecture of everything around it. To understand this motion, it helps to begin close to home. Our solar system moves around the center of the Milky Way at a speed of roughly 500,000 miles per hour. Every star you can see in the night sky is participating in a similar orbit, each tracing a long, slow path around the galactic core. From within this rotating system, the motion feels invisible. We share the same momentum as our neighboring stars, drifting together like leaves floating on a wide, gentle river. But beyond this shared rotation lies a deeper journey. The Milky Way is part of a small family of galaxies known as the Local Group. This collection includes more than 50 known galaxies, dominated by the Milky Way and the Andromeda galaxy. Together, they are bound by gravity, moving through space as a loose but connected system. The Milky Way is not choosing its own isolated path. It is being guided by the combined gravitational influence of its neighbors. When astronomers measure the motion of our galaxy relative to the cosmic background, they find something remarkable. The Milky Way, along with the entire Local Group, is moving at a speed of more than 1 million miles per hour through space. This motion is not random. It has a direction, shaped by immense concentrations of matter far beyond our immediate galactic neighborhood. Even at this tremendous speed, the movement is perfectly smooth, with no sensation of rushing or strain. The direction of this motion points toward a region of space rich in galaxies and mass. This area exerts a subtle but persistent gravitational pull, drawing nearby galaxies toward it over billions of years. The Milky Way's journey is influenced by this distant attraction, like a slow tide shaping the drift of an entire ocean. The galaxy is not being dragged violently. It is responding gently to the curvature of spacetime created by massive structures in the universe. At the same time, the universe itself is expanding. Space between distant galaxies is stretching, carrying them away from one another. This expansion does not feel like motion through space, but rather the growth of space itself. The Milky Way exists within this expanding fabric, embedded in a region where gravity still dominates over cosmic expansion. Locally, gravity wins, keeping galaxies bound together even as the universe grows larger on the grandest scales. This interplay between expansion and gravity defines the Milky Way's true motion. Our galaxy is not racing away from its neighbors, nor is it being torn apart by cosmic forces. Instead, it moves as part of a coherent structure, flowing along with nearby galaxies while the wider universe expands around them. From a cosmic perspective, this is motion without chaos, direction without urgency. Another layer of this journey involves the cosmic web, the vast network of filaments made primarily of dark matter. These filaments connect galaxy clusters across immense distances, forming a structure that resembles a three-dimensional spider's web. The Milky Way sits within one of these filaments, and its motion is guided along this invisible framework. The galaxy's path is shaped not only by visible stars and gas, but by dark matter that cannot be seen directly, yet outweighs everything we can observe. When astronomers map this motion, they do not rely on visual observation alone. They measure tiny shifts in the light from distant galaxies, using these changes to calculate velocities and directions. These measurements reveal that the Milky Way's motion is consistent, persistent, and aligned with the movement of surrounding galaxies. This shared direction reinforces the idea that galaxies are not isolated wanderers, but participants in a collective cosmic flow. From within the Milky Way, this grand journey feels serene. The galaxy does not vibrate or shake as it moves. Stars do not drift from their orbits. Planets remain stable, and life continues undisturbed. Motion on these scales is gentle because it is governed by gravity acting over enormous distances. The forces involved are vast, but they are distributed smoothly, creating stability rather than disruption. The concept of direction itself becomes abstract at these scales. There is no universal north or south, no fixed center of the universe to move toward or away from. The Milky Way's motion is defined relative to other galaxies and the cosmic background. In this sense, movement is relational rather than absolute. Our galaxy is always in motion relative to something else, yet there is no ultimate reference point to declare where it is truly going in an absolute sense. Understanding the Milky Way's true motion invites a quiet shift in perspective. We often imagine ourselves standing still on a stable planet beneath an unmoving sky. In reality, Earth is carried by the sun is carried by the Milky Way, and the Milky Way is carried by the gravitational patterns of the universe. Each layer of motion is nested within another, like a series of slow, harmonious rhythms. This realization does not diminish our sense of place. It enriches it. The Milky Way's journey through the universe is not a frantic escape or a dramatic plunge into the unknown. It is a steady, graceful passage, shaped by forces that have been at work since the earliest moments after the Big Bang. We are not lost in motion. We are held within it. As you imagine this vast movement, it becomes easier to let go of the need for stillness. The galaxy's motion is so smooth that it feels like rest. Knowing that we are traveling through the universe at extraordinary speed, yet feeling complete calm, is a reminder that motion and peace are not opposites. They can coexist, quietly and beautifully. As the Milky Way continues its endless, unhurried journey through the cosmos, far beyond the familiar stars of the Milky Way. Beyond the nearby galaxies of our local group, there exists a region of space that quietly influences the motion of thousands of galaxies, including our own. It does not shine brightly, nor does it announce itself with dramatic explosions or visible boundaries. Instead, it reveals its presence only through gravity. Astronomers call this mysterious region the Great Attractor, and its pull is one of the most profound forces shaping the direction in which the Milky Way is moving. The story of the Great Attractor begins with careful observation. When scientists first measured the motion of nearby galaxies, they noticed something unexpected. Many galaxies in our region of the universe were not moving exactly as predicted by cosmic expansion alone. Their motions showed a subtle but consistent drift toward a particular area of the sky. This movement suggested the presence of a massive concentration of matter, powerful enough to tug entire galaxy groups in its direction. Yet when astronomers looked for it, they found no single, obvious object that could explain the effect. Part of the challenge in observing the Great Attractor lies in our position within the Milky Way, the region of space toward which this gravitational pull points is obscured by dense clouds of gas and dust in our own galaxy. This area, known as the zone of avoidance, blocks visible light and hides distant galaxies from view. It is as if we are trying to look across a foggy valley while standing inside a forest. The obstruction does not mean nothing is there. It simply means the view is incomplete. Despite these obstacles, astronomers have learned to see indirectly. By observing galaxies in other wavelengths of light, such as infrared and radio, and by measuring their velocities, scientists can infer what lies hidden. These studies reveal a vast collection of galaxy clusters and superclusters concentrated in a region associated with the Great Attractor. Rather than being a single object, it appears to be part of a much larger structure, a dense knot in the cosmic web where matter has gathered over billions of years. The Milky Way's relationship with the Great Attractor is not one of a simple orbit in the way planets orbit a star. Instead, it is a slow drift shaped by gravity acting over immense distances. Our galaxy, along with its neighbors in the local group, is being gently pulled toward this region. The motion is subtle, adding a small but significant component to the overall path the Milky Way takes through space. This influence is steady and patient, unfolding over cosmic time rather than human timescales. What makes the Great Attractor especially intriguing is that much of its mass is thought to be dark matter. Dark matter does not emit or absorb light, yet it exerts gravitational force. It forms the backbone of large-scale cosmic structures, guiding the motion of galaxies like an invisible hand. In the case of the Great Attractor, dark matter likely makes up the majority of the mass responsible for the observed gravitational pull. What we can see galaxies, gas, and stars is only the visible frosting on a much larger and seen structure. This hidden nature adds to the sense of quiet mystery. The Milky Way is being influenced by something it cannot see, something that reveals itself only through motion. Yet this is not unusual in the universe. Gravity often speaks more clearly through movement than through light. The paths of galaxies become a kind of cosmic handwriting, tracing the presence of massive structures that would otherwise remain unknown. As the Milky Way responds to this gravitational pull, nothing dramatic occurs within the galaxy itself. Stars continue their orbits, planetary systems remain stable, and the overall structure of the Milky Way is unchanged. The influence of the Great Attractor is distributed across the entire galaxy, affecting its center of mass rather than disturbing its internal balance. This is gravity at its most gentle and expansive, shaping the motion of vast systems without causing local upheaval. The Great Attractor also reminds us that the universe has structure on scales far larger than individual galaxies. Galaxies gather into groups, groups into clusters, and clusters into superclusters, all connected by filaments of dark matter and gas. The Milky Way's motion is part of this larger pattern. We are not moving toward a single destination in isolation. We are flowing along with the cosmic river shaped by the distribution of matter across hundreds of millions of light years. Over time, our understanding of the Great Attractor has evolved. Early interpretations imagined a single, dominant mass pulling everything toward it. More recent observations suggest a more complex picture, with the Great Attractor being one region within an even larger structure known as the Laniakea supercluster. In this view, the Milky Way is part of a vast gravitational basin, slowly drifting toward a common center defined by the collective mass of countless galaxies and dark matter halos. This perspective softens the idea of attraction into something more peaceful. Rather than being drawn into a cosmic trap, the Milky Way is simply following the gentle slope of spacetime created by mass on the largest scales. The motion is not about arrival or collision, but about belonging to a larger structure that has existed for billions of years and will persist long into the future. For a science to sleep by narrative, the Great Attractor becomes less a source of tension and more a symbol of cosmic harmony. Even unseen forces work quietly, guiding galaxies along paths that are stable and enduring. The Milky Way's journey is not chaotic or dangerous. It is guided by the same gravitational laws that keep Earth in orbit around the Sun and the Moon in orbit around Earth. As you imagine this immense, invisible pull, it can be comforting to remember that we are part of a universe that moves with patience. The Great Attractor does not rush, and neither does the Milky Way. Over billions of years, gravity gently shapes the paths of galaxies, creating order on the grandest scales. In that slow, silent motion, there is a sense of calm continuity, a reminder that even the largest journeys can unfold in quiet stillness as the Milky Way continues its graceful drift through the cosmos, on the largest scales imaginable. The universe is not a random scattering of galaxies in empty space. Instead, it is arranged in a vast, intricate pattern known as the cosmic web. This structure is made of immense filaments stretching across hundreds of millions of light years, woven primarily from dark matter, with ordinary matter gas, stars, and galaxies gathered along these invisible threads. The Milky Way is embedded within this web, and its motion through the universe is shaped by the gentle guidance of these enormous, unseen structures. The cosmic web formed in the earliest moments after the Big Bang. Tiny variations in the density of matter, almost imperceptible at first, were amplified by gravity over billions of years. Regions with slightly more matter began to pull in, their surroundings growing denser and more massive. Over time, this process created a network of filaments and nodes, where matter collected into galaxy clusters, while vast voids opened up between them. The result is a universe with structure and rhythm, rather than uniform emptiness. Dark matter plays the central role in this architecture. Although it does not interact with light, it makes up most of the universe's matter and provides the gravitational framework upon which everything else is built. Ordinary matter falls into the gravitational wells carved out by dark matter, tracing the same filamentary patterns. The Milky Way, like nearly all galaxies, resides within one of these filaments, its position and motion shaped by the distribution of dark matter around it. From our perspective, inside the galaxy, the cosmic web is impossible to see directly. The filaments are far too large and diffuse to appear as visible structures in the night sky. Yet their influence is unmistakable when astronomers map the positions and motions of galaxies on the largest scales. These maps reveal long chains of galaxies connected across space, with enormous empty regions between them. The Milky Way is not floating freely in isolation. It is part of this grand, interconnected network. As the Milky Way moves, it does not cut across the cosmic web at random. Instead, its motion is guided along the filament it inhabits, much like a bead sliding along a thread. Gravity gently steers galaxies toward regions of greater mass, encouraging motion along these filaments rather than across the empty voids. This guidance is subtle but persistent, shaping the long-term paths of galaxies over billions of years. This kind of motion is remarkably calm. There are no sudden turns or sharp accelerations. The forces involved act over immense distances, smoothing out any abrupt changes. The Milky Way's journey along the cosmic web is slow and steady, a quiet drifting that preserves the stability of the galaxy and its internal structures. Stars continue their orbits, planets remain undisturbed, and life unfolds without any awareness of the vast gravitational currents carrying the galaxy along. The cosmic web also connects the Milky Way to larger structures, such as galaxy clusters and superclusters. These dense regions act as gravitational anchors, subtly influencing the motion of galaxies within nearby filaments. Over cosmic time, galaxies tend to drift toward these nodes, contributing to the growth of large-scale structures. The Milky Way's motion reflects this process, as it follows the gentle slope of gravitational potential created by the web's densest regions. Understanding this framework reshapes how we think about direction and destination. The Milky Way is not heading toward a single point in empty space. It is moving within a landscape defined by mass and gravity. Its path is determined by the shape of spacetime itself, molded by the distribution of dark matter across the universe. In this sense, the cosmic web is not just a structure, but a guide, quietly shaping the movement of galaxies without forceful intervention. The existence of the cosmic web also explains why the universe looks the way it does. Galaxies are not evenly spread out because gravity naturally draws matter into filaments and clusters. The vast voids between these structures are not empty by accident. They are regions where matter was pulled away, behind enormous expanses of near-nothingness. The Milky Way's location within a filament places it in a region of relative density, surrounded by other galaxies following similar paths. For a science to sleep by narrative, the cosmic web offers a deeply soothing image. Imagine the Milky Way as a luminous strand of light, woven into a much larger tapestry that spans the universe. Its motion is not hurried or uncertain. It is guided, supported, and connected. Even the unseen components of the cosmos work together to create balance and continuity. As you picture this immense network, it becomes easier to release the idea of isolation. Our galaxy is not lost in a dark, empty universe. It is part of a vast structure that has been forming since the beginning of time, shaped by gravity and guided by dark matter. The Milky Way rides these cosmic currents with effortless grace, carried along paths laid down billions of years ago. In the quiet of the night, when the sky feels still and distant, the cosmic web continues its silent work. Galaxies drift along filaments, clusters slowly grow, and the universe evolves with patient consistency. The Milky Way's motion through this web is gentle and unbroken, a reminder that even on the largest scales, the universe prefers harmony over haste. Wrapped in this invisible structure, our galaxy moves calmly forward, woven into the grand design of the cosmos. Carried softly through space and time, the Milky Way is not alone in its journey through the universe. It belongs to a small, intimate family of galaxies known as the Local Group, a collection of more than 50 galaxies bound together by gravity. At the heart of this group are two large spiral galaxies, the Milky Way and the Andromeda galaxy, accompanied by dozens of smaller dwarf galaxies that orbit and drift around them. Together, they perform a slow, graceful dance that has been unfolding for billions of years. From a distance, the local group might appear chaotic, with galaxies scattered in different directions. But beneath this apparent disorder lies a quiet structure shaped by gravity. Each galaxy follows a path influenced by the mass of its neighbors, moving in response to forces that are steady and predictable over cosmic time. The Milky Way and Andromeda dominate this dance, their immense masses shaping the motion of the smaller galaxies around them. The relationship between the Milky Way and Andromeda is especially significant. These two galaxies are approaching each other at a speed of about 250,000 miles per hour. While that number sounds dramatic, the distance between them is so vast, more than 2.5 million light-years, that their approach is almost imperceptible on human timescales. Over thousands of years, the change is subtle. Over billions of years, it becomes inevitable. This approach is not the result of a sudden attraction, but of a long-standing gravitational bond. The Milky Way and Andromeda formed relatively close to one another in the early universe, emerging from the same region of the cosmic web. As the universe expanded, gravity worked quietly to slow and eventually reverse their separation. Now, long after their formation, They are gently falling toward each other, guided by the curvature of spacetime they share. Around these two giants, smaller galaxies move in more complex patterns. Dwarf galaxies orbit the Milky Way and Andromeda, sometimes captured, sometimes torn apart, and sometimes flung into new trajectories. These interactions are not violent in the everyday sense. They unfold slowly, with stars responding gradually to shifting gravitational fields. Over time, smaller galaxies can be stretched into streams of stars, leaving delicate traces that wrap around their larger hosts. The local group's motion is also influenced by dark matter. Each galaxy is embedded in a halo of dark matter that extends far beyond its visible stars. These halos overlap and interact, deepening the gravitational connection between galaxies. The dark matter within the local group acts like an invisible dance floor, shaping the steps and rhythms of the galaxies moving across it. Without dark matter, the local group would not remain bound, and its gentle choreography would fall apart. What makes this dance so peaceful is its timescale. The motions are slow, the forces evenly distributed, and the distances immense. There are no sudden collisions or explosive encounters. Instead, galaxies respond gradually, adjusting their paths as gravity quietly guides them. From within the Milky Way, this dance is completely imperceptible. Stars continue their orbits, planetary systems remain stable, and life on Earth unfolds without any hint of the cosmic motion surrounding it. The local group also moves as a whole through space, responding to the gravitational pull of larger structures beyond it. While the Milky Way and Andromeda draw closer to each other, the entire group drifts together along the cosmic web. This layered motion, galaxies orbiting one another while the group itself moves through the universe, adds depth and complexity to the Milky Way's journey.